Good morning, everyone. The title of my study is Sensitivity of Apple Rootstocks to Water Stress. Just to give you a brief background, rootstocks are very important in apple production as they affect the growth and productivity of the entire tree. However, there are still knowledge gaps regarding how rootstock may differentially affect apple tree water relations and under water deficits. So the purpose of this study is to provide quantitative information to either confirm or disprove that the hypothesis that more dwarfing and more vigorous rootstocks exhibit differential drought resistance mechanisms under South African conditions. I'm going to look at two main objectives, which is to measure whole tree transpiration rates of rosy glow apple trees on rootstocks of varying vigor before, during, and after water deficit periods compared to well-watered trees, and also to assess the influence of soil moisture dynamics during water deficit cycles on tree transpiration responses. This experiment was carried out in the Wittenberg Valley at Parekloof. We were using 50 trees in 3 different rows, and these trees were planted in December 2010, and they all had one rosy glow scion cultivar on 5 different rootstocks. The rootstocks were RN29, MM109 with the M9 interstock, CG222, M7, and M793 in order of increasing vigor. The experimental design was a randomized complete block design with 2 factors, that is irrigation and rootstock, all in 5 different blocks. So we had 2 irrigation treatments. 25 trees were well watered, and then the other 25 trees were subjected to drought stress. And this was done by, I'm not sure if you can turn off the light. Okay, just to show you, by clamping off irrigation on both sides of each of the drought-stressed trees, and then additional soil moisture measurements were also done using the CS616 soil moisture sensors at different depths. And then for gaseous exchange measurements, we also used the LI6800 photo system. These are some of the results that we obtained. For volumetric water content, under well-watered conditions, at 15, 30, 60, and 40 centimeter depths, we saw that there was little variation throughout the experimental period between January and April. But under drought-stressed conditions, you can clearly see the 2 drought cycles that we imposed on the 25 trees between 15 January and 12 February, and between 5 March and 2 April. As you can see, there was a clear decrease in the volumetric water content, which is what we expected to see. We also did diurnal trends in transpiration for all the 5 different rootstocks under well-watered and drought-stress conditions. The blue lines generally show, like for all the rootstocks, the blue lines show the well-watered treatments, whilst the orange ones show the droughted treatments. And this was just done before inducing drought stress, and as you can see, there were little differences between the well-watered trees compared to the drought-stressed trees before we induced drought stress. On day 13 of inducing drought stress, that's when we saw the greatest difference between the well-watered trees and the drought-stressed trees. In general, the highest transpiration rate was observed with M793, whilst the lowest was observed with CG222, which is a relatively low vigor compared to M793. And this indicates that these rootstocks have different mechanisms that they use to deal with water stress. For example, like a rootstock such as CG222 may actually close their stomata during water deficits to prevent desiccation. Okay, just to show you what happened after the inducing drought stress, we can clearly see that there were still some differences between the well water treatments for MM109 and the drought stress treatments. But for the other 4 rootstocks, the transpiration rate was still relatively the same, showing that MM109 may recover from drought stress at a lower rate compared to the other 4 rootstocks. Just to conclude, these are just preliminary results. So we have confirmed that the resistance to water deficit also occurs through either drought avoidance or drought tolerance mechanisms. And for RN29, from the results that I showed you, it's clear that it avoids drought through reducing transpiration rate. And then for the more vigorous rootstocks such as M793, they show tolerance to water deficits by maintaining high transpiration rates. Okay, thank you.